Interestingly, there are also instances where these operators can be used on strings. That might seem strange since most of these operators heavily suggest something mathematical or something numeric, like plus and minus. The mathematical operators obviously work on numbers, and the relational operators typically focus on numerical relationships as well. However, some of those operators still work on strings of characters. We've seen one example of this already. The addition operator, when applied to strings, puts two strings together into one string. Here, we start with the string hello world on line 2. And on line 5, we add an exclamation point to it. The result is the text, hello world, is the output, including the exclamation point. But this is probably the only mathematical operator that works on strings, right? I mean, addition to add two strings together makes sense, but how would you multiply a string, or divide a string, or subtract a string? How would you say that one string is greater than another string? Well, perhaps surprisingly, our relational operators work fine on strings as well. It's not too surprising that the equality operator works since it makes sense to check if two strings have the same characters, but what does it mean for one string to be greater than the other? Well, we've already talked about this a bit in the past. In this context, it means the string comes later alphabetically. A string is greater than another string if when sorted alphabetically, it comes later. This allows string sorting to mimic numeric sorting. Just as when you sort numbers numerically, the bigger ones come later, when you sort things alphabetically, the later ones in the alphabet come later, so they have greater values. So here's an example of this. We create 3 strings, my A string, my B string, my C string, and give them very simple values, the string A, the string B, and the string C. On line 5, we check, is my A string less than my B string? Well, A comes before B alphabetically, and so we do say that A is less than B alphabetically. And so it's true that my A string is less than my B string. Line 6 asks the same kind of question for C and A. Is C less than A? Well, no, C comes later alphabetically, so C is greater than A alphabetically, and so it's false. And finally on line 7, we can see string equality in action. Is my A string the same as my A string? Well, by definition, this is always going to be true. Whenever we have the same variable on both sides of an equality comparison, they're going to be equal. But more importantly, we can also see that A is in fact equal to A, and so this is true. We can use these equality operators to sort our strings alphabetically. However, beware, Python sorts uppercase and lowercase separately. Take a look at this for example. On lines 1 through 3, we again create strings, but our values here are uppercase A, lowercase a, and uppercase b. Intuitively, we know that the uppercase b should still come after the lowercase a if we sort alphabetically, right? However, when we run our comparisons, that's not the case. On line 5, we check again to see if a is less than b, and as expected, it still is because it still comes earlier alphabetically. In line 6, though, we check to see if a capital A is less than a lowercase a. Generally, we would probably say no. We would probably say those are the same letter, and if you're sorting, you shouldn't move one ahead of the other based only on which one's capitalized. And yet, Python disagrees. It does see a capital A as being less than a lowercase a. So if you sort a bunch of strings that all start with the letter A, but some are capitalized and others aren't, Python is going to put all the ones with a capital A before any of the ones with a lowercase a, because it sees the uppercase a as being less than the lowercase a. That might not be a huge issue, but it becomes a bigger issue on line 7. Here we ask if a lowercase a is less than a lowercase b. Less means it should come earlier alphabetically. And indeed, a lowercase a should come before an uppercase b alphabetically. And yet Python disagrees again. It says that it's false that a lowercase a is less than or before an uppercase b. This is one of the things that makes dealing with strings complicated. Strings represent human language, and human language is very complicated. Finally, there's one last surprising instance of operators understanding their context. It happens when we try to multiply a string by an integer. That doesn't sound like it makes any logical sense to us, does it? How do you multiply text by a number? Python, interestingly enough, has an interpretation for this. In this code, we create a string called myAstring with the value a again, and we create a variable named myInt that holds the integer 5. On line 4, we try to multiply that string by that integer. Multiply a string by an integer? What does that even mean? Well, Python has a meaning for it. It takes that string and multiplies it out that many times. As far as Python is concerned, we asked for 5 A's, so we got 5 A's. Interestingly, this is the only mathematical operator that works this way for strings. You can't divide strings or add integers to strings or anything like that. And it only works with a string times an integer. You can't multiply a string times a floating point number. And truth be told, you might never actually find a practical application for this. Honestly, I only discovered this when I tried to find an example of a data type that couldn't be multiplied by another data type. And I stumbled upon this by accident. Still though, it's an interesting look into some of the surprising things that Python is able to do.